Hi Year 13, we are going to, in our lesson today, start thinking about enthalpy changes. Now the enthalpy change is defined, as you can see at the top of page 7, as a change in energy at constant pressure. Now we've covered exothermic reactions before. Because heat energy is always given out, delta H will be negative, and in endothermic reactions, because heat energy is taken in, delta H will be positive. Now the enthalpy change is quite often given the symbol delta H with this wee funny circle with a line through it, and that funny circle indicates that the enthalpy change is happening under standard conditions. Standard conditions are, if you write them into your notes, 100 kilopascals of pressure, 298 Kelvin, and 1 mole per decimetre cubed if we're dealing with solutions. Now we'll keep coming back to these standard conditions. We've got 4 definitions that we're going to cover this lesson, and the first definition is for the standard state. Now if you can write into your notes, the standard state of a substance is its most stable state under standard conditions, which we just mentioned, and that can be solid, liquid or gas. Our next definition is for the standard enthalpy of combustion, quite often given the symbol delta HF. Now we are going to type into our notes the definition for this standard enthalpy of formation, or I should have said, write into your notes. Now, the standard enthalpy of formation, and it's really important that you write it in word for word, is the enthalpy change when 1 mole, and it's always 1 mole, this is what this enthalpy means, of a compound is formed from its constituent, that's just the elements that make it up, from its constituent elements in their standard states at 298 Kelvin and 100 kilopascals of pressure. Or we could have simply said under standard conditions. Okay. Now there's a space in your notes then to write in the example of where we're forming 1 mole of a substance. And we're going to pop in the example then of forming 1 mole of water. Now 1 mole of water will be formed from some hydrogen, and it's important to pop in the state symbols, some oxygen, to form water. Now if you look carefully at the definition, where the definition states that we have to form 1 mole of water, so therefore I need to balance my symbol equation up, and if I look carefully at it then, I'm only going to require half a molecule of oxygen. Now there's one example of the equation to show the delta HF of water. Okay, now at the top of page 8 then you've got a note, and the note's down at the bottom of the screen there. Because we don't need to form an element from any constituent elements, the standard enthalpy of a formation of an element in its standard state is defined as 0, if you can write that in at the top of page 8. Now our next definition that we need to cover is for the standard enthalpy of combustion. Now I've said to you that enthalpy always takes to do with 1 mole, so therefore it'll always take to do with 1 mole, it'll still be 1 mole I should say, for the standard enthalpy of combustion. Now we're going to write in the definition. This is the enthalpy change when 1 mole of a substance is burned, that's what combustion means, completely in oxygen. And this time I'm just going to put under standard conditions, but I could list those standard conditions if I wanted to. Under standard conditions. Okay, now like before, we're going to write an equation to illustrate this standard way of combustion then. And if you look at the screen now, you'll see that we have got the equation for the standard enthalpy of combustion of glucose. So I'm burning by definition 1 mole of this glucose in oxygen, and the products when I burn this glucose will be carbon dioxide and water. But the important bit is that we're always burning 1 mole of whatever substance. In this example, like I said, it's glucose. And it's important that you pop the state symbols in there. Now our last definition, now using the two definitions that we've covered, you could probably guess that it's going to be the enthalpy change when 1 mole, and again this 1 mole is really important, of water is produced in a neutralization reaction under standard conditions. And there's the example of a neutralization reaction where we have formed 1 mole of water. Now, you'll see for each definition there, for our delta HF, our delta HC, and our delta HN that we've covered, we're asked for the units. Now, the units are always going to be the same for each of them, so if you can fill into the space for each definition, that the units will always be kilojoules per mole. Now, it's important that you learn these definitions and be really familiar with them, because as we all go on through this energetics unit, you'll come to these definitions again and again and again and again. Now, you can see in your notes that we've got from page 9 to 11, we're going to get a wee bit of practice at writing out these equations for delta HF and delta HC. If you can do that for next lesson. Thanks. Of